Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 53 off the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we're looking for the graph that best represents a function with a range of all real numbers greater than or equal to -6. So let's define our terms here. Sometimes we are asked for the domain. The domain is going to be all of our independent variable values. And so that's typically going to be our x values. And when we're looking for the range, which is what we are doing in this particular problem, it's going to be our y values, or all our dependent variable values. Now, I said y values, but sometimes if we're not necessarily looking at a graph, it might be like f of x, it might even be g of x, h of x, whatever of x. Since we are looking at graphs, we are going to use this y values right here. So we're looking for a range of all real numbers greater than or equal to -6. Okay, so what does that mean? Well, that means that if we wanted to show it mathematically, it's going to be greater than or equal to -6. So most of our quadratics here, these are all parabolas, which means they're all quadratics. We know they're quadratics because they have that parabola shape, and our standard form is ax² plus bx plus c. It's this squared right here, that degree of 2. That's what makes it a quadratic. That's what gives it the parabola shape. Most of the time, our domain is going to be all real numbers. You're really not going to see a domain that's restricted unless you see half of a parabola, or they chop off part of the parabola. So all of these parabolas right here have a domain that looks like this, right? X is greater than -infinity, less than infinity. The y values happen to be restricted because there's always going to be a vertex. And that's what we're looking for here. So let's look at our vertex. So you see this vertex right here, y value. We're looking for the y value. Well, that y value is, and you see we've got this -6, 0. That's the actual point of that vertex. We're just looking at that 0 right there. So we could say that our range of this one is y is going to be greater than or equal to, because we are going to include that 0. -6 isn't even showing up yet. That's the x value, and it's not really important unless we're wanting to plot the parabola. So obviously this is not what we're looking for. That's what we'll be doing here. So we do, thankfully, on B, take a look at this right here, we do get at least a -6, but, so our y value is -6, which is what we're looking for, but look, y, that's the height of our parabola, that's the top point. That vertex, everything else is below. This is y is going to be less than or equal to -6. And so it's close, but we're wanting a greater than or equal to. So we need this to flip up. That parabola with a flipped up graph, that would look good. C. Well, that's exactly what we were just looking for. Look, we've got a vertex of 0, -6, and it's moving up. So we have our values of y greater than or equal to -6. That looks good. Let's double, once again, this goes over here to -6, but that's not what we're looking for. It's really just -6, 0. So it's got a y value of 0. So this is like the opposite of A. It's going to be less than or equal to 0, because 0 is your vertex there, and it just moves down from there. So our answer here is C.